All right, that I think looks good. It's not showing me what it's showing me or what's it showing you guys. So we'll hope it looks good here.
Yep, looks good.
All right. This is not showing me my notes. Because why? Well, that was actually probably the most benign problem that could happen. So we'll just wait until a better one happens. The World Wide Web was invented in 1990. I was 7. Yeah, I was 7. Definitely more interested in Transformers. So it's been 30 years, an eternity in technology time. The web's an adult now, and a lot has changed. From this. This here is the very first website, reproduced in 92, and it's perfect. No distractions from the content. It's very easy to read, easy to analyze. Got no images, no pesky JavaScript trying to pop up windows and advertisements, and no under construction GIFs, which, well, I guess we can't have everything. And then the first big event in the web came in 94 that opened up the World Wide Web to the, world. Was the release of Mosaic, which was one of the first widely used, among the people on the web at the time, graphical browsers. So you can see here now I've got a web page and it has an image on it. So now we can use the web for its intended and only purpose, sharing cat pictures. But unfortunately, time marches on. A few years later, we had the release of version 4 of both Internet Explorer and Netscape Navigator. And this is what started off, it started looking almost kind of like a modern website. These are the first browsers with any kind of recognizable modern features. But this was also the start of the infamous browser wars, in which many people lost their lives. Each vendor trying to make their browser the one browser to rule them all. And to get users to their browser, they would build extensions to websites that only worked in their browser. If you're old enough, you may recall this site is best viewed in Internet Explorer version 5. So after they laid waste to much of my sanity, from the ashes of the lawsuits rose a push for standardization. And the standards then are the blueprints that allow us to build the modern web. So I've now reached the year 2000, the new millennium, and I've still got 20 years to go here. So our history lesson is going to get split up here into a couple different topics. First, I'm going to talk about web design, which is how we present web content. And then I'm going to talk about web apps, which is how we use the web interactively, seeing it's not a read-only medium. So starting with design, let's look again back at that first web page. Elegance in its simplicity. We've got our content. We can link to other content. We can use some headings to and some lists to organize our content. But some folks had this crazy kind of idea that they wanted to put blocks of text side by side, like I don't know, some sort of like newspaper. And And as screen resolutions increased, at this time, we almost had a photorealistic 1024 by 768. The longer lines of text became harder and harder to read. So in 1995, we got the HTML table element, which allows for tables of data, like Excel spreadsheets. But when Netscape implemented it, they allowed you to set borders to 0, to set the spacing between cells to 0, and the padding in a cell to 0. So our table that once looked like this could be able to look like this. And from here, we have a very, very basic tool for laying out parts of a web page. And it was okay. I can make header, body, sidebar, footer, very classic now web page layout. But there were some issues to deal with. First and foremost, this kind of layout is a lot of work. You've got to arrange all of your content in rows and columns. Everything other than content is going to have to be an image. So you've got images for borders, images for backgrounds, images for circles, round borders, everything. And if the image doesn't fit where you want it, you ended up having to slice it to fit into each table cell. There were indeed programs that would do this for you. Adobe Photoshop could slice up an image for an HTML table. That's how often we had to do this kind of thing, which led to our second problem here. Tables aren't meant for this. They're meant to display content. So the browsers would try to resize table cells to fit the content inside them, which, well, ends up breaking your design. So you fix that by setting widths for every single cell. And then you figure out that the browser ignores that when it feels like it. So you start adding single invisible pixel images to make sure that there's some content in those cells to keep them open and keep everything exactly the way you want it so that the browser doesn't go and resize it. And if that wasn't enough, we have our page's shell, but what if we want columns then in our body section? Well, the solution then is more tables. And more tables is a lot more work. So for example, here, I've got this pretty simple website. Looks pretty innocent, simple, clean. This is what it looks like with every single element outlined. They're everywhere. There's a good 200, 100 elements probably on this simple page. Here is the code for that. That's how small I had to make that for this to fit on this slide. And if you can see all the blank space there, so much of this is just setting up rows and columns, and not as much is the actual content. So tables are complex, tables are slow, and tables are hard to maintain. So no matter what anyone tells you, these were not the good old days. No matter what anybody who hates CSS or whatever, these were not good old days. I much prefer now. So let's skip ahead then to 2002. CSS has been around for a few years now, but support for it is finally good enough that we can start using it. So this would be IE6, Netscape 7, and we can start using one of its main features, which are called floats. Now these were designed to be able to float our cat pictures around some text. You can see how the bottom paragraph there flows underneath that image. And before CSS, we did that within a line attribute on the image itself. But in CSS, you can float anything, even just plain pieces of content. So here again, we have the makings of a basic kind of layout. But floats are awkward. Again, this really isn't meant to do layouts. They have a lot of special rules that take some getting used to. First and foremost, they're allowed to overflow. So you can see here, my cat picture is outside of my paragraph. And then if I try to add another paragraph, well, that doesn't really look right. And this will break your layout. So to fix this, you're going to have to add this clear property to make the next element skip past any floats. So you can see now it's doing approximately what I wanted. But often to clear these things, I have to add more markup. That's just purpose is just to make sure that the next thing starts on the next line. Another kind of weird quirk is that in these float-based layouts, the order of the elements in the markup matters. And often it's not the natural order of reading, top to bottom, left to right. So for example, here, what I did wrong was I have these three elements in the order, left, center, right. The left one here is floated left, and the right one is floated right. And this seems natural and logical, but this is the result. To fix this, what I actually have to do is I have to put the right column before the center column. So it's kind of weird, kind of unnatural, and it takes getting used to. Speaking of the center, there is no center. There's no way to float center. If you want to center, you're going to have to wrap your floats in a container, which is even more markup. And at that point, we might as well just use tables. So despite all this, a website was invented called the CSS Zen Garden. And its goal was to give you the markup and you create a CSS file to change it to make it look however you want. And there were some wild things that you can do just by changing the CSS of a page. One such example here is this. So this is the exact same page, but with different CSS. And I close my speaker view here, so because it doesn't play. There we go. So the same CSS, or sorry, a different CSS, the same HTML, and it looks completely different. So this CSS Zen Garden indeed is one of the sites that really popularized using CSS and going away from tables. So all these quirks ended up resulting in a bunch of patterns. And in 2008, these patterns kind of became formalized into what became the 12-column grid. Largely, it was 12 columns because 12 is a nice even number that's readily divisible by a whole bunch of other numbers. So you can see here, there's a lot of different ways we can take 12 columns and mix them up. And so we took this grid framework, this grid library, and it was pretty good if we didn't think about it too much. But it's still a bunch of extra markup. At this point, we're now still doing our rows and columns. Our columns can contain other rows, and we don't have to like nest things so badly. But the real kind of nail in the coffin of this float-based layouts was the beginning of the mobile web, starting in late 2000s. The problem with this float layout here is that it's kind of a fixed grid. We have to set the widths of all of these columns precisely. And that's not responsive for a very, very small screen like we've got on our phone. So the first thing we tried to do to fix this is we'd create a mobile site. So if a phone tried to hit our website, we'd redirect it to a different site. So we'd maintain 2 websites, and often they were the same. Sometimes they were less so. And often we also, I'd be on my desktop and I'd get to the mobile Wikipedia, which never worked out very well. So to solve this one, in 2009, we had media queries, which allowed us to apply different kinds of CSS based on the device that was viewing the web page. So for example, normally I could have 12 columns, but then perhaps when it's on a tablet, there's only 4 columns. And when it's on a phone, there's only 1 column. And so we do this through breakpoints. So for example, here, all of the CSS in those curly braces will be applied only until the browser is 450 pixels wide. And then I can have another set of rules for 451 pixels to 1024 pixels. And I can have another set of rules for anything larger than 1024. So I can get my phone, my tablet, and my desktop, each having kind of their own style sheet. And remember from the CSS Zen Garden that using a style sheet, I can make any change I want, provided my markup is well designed. But this isn't fluid. This is like a set of breakpoints. So like, what happens if there's a browser that's 600 pixels that doesn't look very good on? What do I do then? Well, I add more breakpoints and more breakpoints and more breakpoints. And unfortunately, we're still using floats, so the order of the markup still matters. So I am still rearranging markup to make sure that the right ones are seen in the right order. And this all became solved. This all got solved finally in 2015. We're now getting quite recent with the flexible box model. So Flexbox allows us to put elements side by side, much like floats and tables did. But it also lets us grow and shrink those elements based on whatever rules we want. We can expand and contract the space between elements. We can wrap the elements so they can grow to a certain size and then start unwrapping themselves, or shrink to a certain size and then start wrapping. And we can align the 2 axes, the vertical and horizontal axes, so that it looks like columns. So this is kind of the first thing that we could say is actually fluid. We can more easily take a single page and make it look good on any device for any size, no matter what kind of devices are made in the future. We can resize, we can reflow, and we can even reorder the content. Flex has a feature where we can say that this 3rd column here should actually be shown visually as the 2nd column, which is actually quite handy, especially when you're talking about like moving navigation bars from the side to the top. There is one limitation of Flexbox, and it's that it is one axis. So a Flexbox goes either left or right or up and down, not both. So to address this, in 2017, we were finally able, support was finally there so that we could use the CSS Grid, which is very similar to Flexbox, except on 2 axes. But there's a lot of complexity here. We can arrange elements in rows and columns. We can assign elements to named rows and named columns. So we can name a column like sidebar, and then any element that we want to put in our sidebar, we just say, here, put this, assign this sidebar. or assign this to the header, or assign this to the footer. So order becomes even less of a concern in the markup. We can then auto-fit all of our columns and auto-fill them. So if our screen can support 6 columns, it'll fill 6 columns. If it can only support 4 columns, it'll fill 4 columns. And these are all settings that you can play around with to make sure that your site looks how you want it. So this is our second truly responsive framework for building layouts without having to set specific breakpoints in our CSS. So we don't have to go around to various devices, figure out how big their screens are, and codify that in our CSS. That's still available if we need to. Unfortunately, Flexbox and Grid aren't perfect, but I have not really found a need for those recently in my designs. So there is one problem with the Grid. Unfortunately, it's brand new. Like I said, 2017 basic support was finally there enough that we could use it. And so some of the support varies. There were some things that were still kind of up in the air and in flux as recent as a couple years ago. So there's a website out there called caniuse.com where you can type in whatever modern web feature you want, and you can see which web browsers support that feature. So if you have to support, for example, IE 11, you can type in Grid and see that, oh, okay, IE 11 does support Grid. If you have to support IE 8, well, I'm sorry, but you can still type in whatever you want and see if IE 8 supports it. So that's kind of the history and present of web design. We don't want to use tables anymore. Tables are for data. We definitely don't want to use floats anymore. Floats are for flowing text around things. We do want to use Flexbox. And we absolutely, if we can, want to use Grid. The Flexbox and Grid are really, really easy. I'm actually surprised at how easy it is now to design web pages after doing so many table-based layouts. It's just such a nice nice feature. So that's basically all you need to know about modern web design. So let's talk a little bit about the interaction, the interactive web. So back in the good old days, we had one way to get user import. We had a form. We had one way to read and write data. That was HTTP, so full page loads. We had one way to store data on the user's computer, cookies, which if they enable them, and that's a whole other brouhaha. And if we wanted like actual fluid, like animated and or interesting UI or UX, our only option was Java or Flash. In fact, Microsoft's front page used Java for its hover menus, and a lot of websites, even some that I built, ended up using Flash just for the menu of the website, so that it could look nice when you hovered over, because that's the kind of thing that users actually care about. It wasn't until 1998 where we were finally able to actually animate HTML itself. And the browser vendors called this DHTML, dynamic HTML. And this was a precursor to what we know today as the DOM, which means that it wasn't a standard. As a matter of fact, Netscape implemented something called a layer tag, which you accessed from JavaScript through the layers attribute. IE introduced something called a div tag, which was actually standard at the time, and then created something called document.all. I still to this day see JavaScript looking at document.all to see if they're on IE or not. But that wasn't going to work very well. So not very much interesting things were happening yet until we hit 2002. So in 2002, we got some very interesting things. The XML HTTP request, what you may now know as AJAX, allows you to request data without reloading the entire page. So you could finally actually have essentially a single page application. You go to the page, and then any other updates you need to make to that page happen asynchronously without reloading the whole thing. But I think the more important one was the document object model, the DOM. At this time in 2002, it was slow, it was awkward, it was verbose, it was incompatible, but it was the start of web standards for everything. There's this standard way to script a web page that the browser vendors can't just use whatever they want and expect things to work. I, for example, was never going to write VB script for a web page. So fast forwarding a little bit to 2006, we get some very interesting things too. We finally have JSON, which means that the JavaScript object notation is a much easier way than XML to transmit data, which means that now we can finally call it AJAX, which means asynchronous JavaScript and XML, despite the fact that we only use JSON. So, okay. But arguably, one of the more important the more important development was the jQuery library. jQuery took all of those differences between the browsers and just eliminated them. The jQuery library kind of pushed JavaScript forward. JavaScript had been kind of stalled in language development since 1990 something. They were trying to build classes and types and all sorts of things that nobody actually wanted. So jQuery was what people wanted. A few years later, we see jQuery's features get supported natively in the browser. So that's the query selector. jQuery's kind of most standard feature was the ability to select JavaScript elements using CSS selector syntax, which is much easier than looking for those elements either just by their ID or worse, trying to like navigate the DOM tree manually. Just no, don't try it. But so now that same jQuery feature is available to us just natively in the browser, no library required. But another interesting thing that started the web kind of down towards more of an application platform was local storage. So previously we only had cookies, so we could just a few bytes of data that got passed back and forth between the browser and the server. So we could do logins, and that's about it. Maybe remember some preferences. But local storage allows us to work with some persistent storage just as though it was a JavaScript object. And we could set quite a bit of information there. And better, that information never had to be sent back to the server. like cookies did. Cookies had to be sent back and forth every single request. So this is kind of the start of the browser as an application platform, which eventually started really ramping up around 2012, which that's not ominous. In 2012, we started having a new set of libraries for responding to changes, either by the user or we have AJAX from the requests that we're sending, called data binding. And in this, what we do is we link data in a JavaScript object to a place in the web page, in the DOM. And then whenever that data changes, we re-render the DOM automatically. So for me as a developer, all I have to do is kind of set up these links and then assign to variables, and the page gets updated. So some of the popular libraries for this are, okay, my coworker just seems to have hit the keyboard here, and I have no idea what button she pushed. Huh, nope, that's not it. Awesome.
Try escape. Yeah, there you go.
Well, reloading it always works, right? That's what we restart it, and that works. And then we restart this, and oh, hey, I can see my notes finally. So, data binding then. The libraries, you've probably heard of React, AngularJS, not to be confused with Angular, which is its successor. But the original AngularJS I actually used quite a bit, and it was much simpler to easier to kind of drop in to a web page and just use. And Vue is definitely the one I recommend now, as it has the same kind of philosophy as AngularJS, in that you can just drop it in a web page and then pick a spot of that web page to control, and have kind of a reactive data binding application. It really reduces the amount of code you have to write to have a dynamic section of your website, which is really nice. And then the other thing that we got around 2012 was support for WebSockets. So WebSockets allows us, instead of having the browser request something, we can push out an update to the browser. Many technologies had been tried for this before. I don't remember one of them that actually worked. I kept hearing about the fabled server push. There were a lot of very weird ways of trying it, and nothing really worked very well. So WebSockets have been a very fun thing. Also well supported by Mojolicious, hint, hint. So this as bidirectional socket allows us to transfer messages back and forth. But it's not a TCP socket. This isn't a stream. You're not going to want to send videos or large files through this. So we're still going to need HTTP for some things. And the last thing we kind of got access to was CSS animations. So previously, really the only way to animate a web page was either tedious JavaScript, which kind of slow, or, well, Flash, also kind of slow. CSS animations allows for some very fluid, complex animations, but also very simple ones. This one, for example, here is a simple kind of, not going to let me replay it, a simple transform, transition. Not much to that. So we can then also trigger these animations through JavaScript. So I can set up a fade in and out animation. And then if I add a class to an element, that element fades in or that element fades out. Or maybe that element slides in from the left or the right. As a matter of fact, if I had transitions enabled in this presentation, that's how it works. So 2012, definitely we're starting to look like potentially real, I suppose by real I mean desktop applications. And finally, on our little historical journey here, 2016 gives us a few interesting things. The most interesting of which is ECMAScript 6 or JavaScript 6, which is just a massive enhancement of the JavaScript language. It's got actual class syntax, which may or may not be interesting to you, but it has a lot of features for decreasing the verbosity of your JavaScript. JavaScript is a lot easier to write, though perhaps it's a bunch of stuff that you have to learn, which if only there was some language that had that same problem, where the longer you work on it, the shorter the code gets and the harder it is to understand. I'm sure it'll come to me as a pearl of wisdom. But there were also some other things. Oops. IndexDB is interesting in that it's just an actual database. Local storage is just an object. IndexDB is a schema'd, asynchronous, and quite complex database right in the browser. It doesn't use SQL. Actually, there was a WebSQL attempt, and then it turned out that everybody used SQLite, and since there had to be at least 2 implementations, it turned out that nobody was actually going to rewrite SQLite. So that was scrapped for this. I don't recommend using IndexDB directly. As mentioned, it's complex, but there's a library called Dexy, which is quite simple, actually. It's very, very nice, very easy to use. And again, this kind of allows more local information, more local work to be done by a web app, as opposed to having everything be done on the server. SVGs are one of my favorite things. I don't know if they're important enough to mention too much about. This stands for Scalable Vector Graphics, which is basically it's XML that shows you a vector graphic. This was actually released in 2001, and I had given up hope, but finally, in 2016, it's now supported enough that I could actually use it. So you can actually put these things right in your web page, just type it right in. And it largely replaces a lot of things that we had to use Flash for previously. But also, fun thing is you can use CSS to style these things. So you can have SVGs that change on hover based on whatever style you want. You can create one generic SVG file and then use it to create a whole array of different colored buttons or stars or what have you. This is a very, very useful feature. Charts, I know a lot of chart libraries are starting to use this. Excuse me. And there are some presentation software that uses SVGs to try to scale text as big as it can go. There are a lot of, especially with data binding, there's some interesting things you can do with SVGs. So up next, what's something that you should be looking at right now, maybe that you can't use, but something that you should kind of keep an eye on to see where things are going. If you just came from Grahamstock, WebAssembly is finally reaching some usable places. This, as he described, is more like a sandbox for user code, for code, which is like exactly what a browser needs. Because I, as a user, I go to a website, and that website gets to run code on my machine, whatever it wants. And so having a sandbox allows us to basically protect the user from the website author. Some of you may remember the early days of JavaScript where you could do very, very bad, terrible, ugly things to users, like an infinite set of alert boxes that would basically, the only way out would be to restart your computer with JavaScript. Yeah, you could lock up a computer with JavaScript. But WebAssembly is also a compile target. So you can take, I don't know, C code, compile it to WebAssembly, Perl code, compile it to WebAssembly. I can finally, again, write Perl script. I haven't been able to write Perl script since IE3. WebRTC is a new one, very interesting. There's an IRC client project called Convos that has added WebRTC support. And what this stands for is real-time communication. And what this lets us do is this nice Zoom sharing video, audio stuff, but over the web. So through a browser, anybody can do it. We don't need to install more software, and we don't need to know who we can trust. But one of the more interesting things that's really just on the cusp is it's called service workers. And that doesn't really describe what it does. One of the things that service workers do is, so it's another process essentially that runs JavaScript kind of outside of your website. It doesn't have a web page, but allows you to do synchronizations kind of offline. But it also allows you to, when the browser is offline, handle requests from it. So say, for example, you're on a phone. You've got, some notes app that you've got open in a web browser, and you're going through a tunnel on the train. Every time you lose connection to the internet, your service worker can be handling those changes and queuing them up, caching them, waiting for the next time that you get internet connectivity, and then send all of those changes to the server. So to the user, it doesn't look like anything's changed. The requests are still being responded to, but they aren't being responded to by a server. They're being responded to by your service worker. So these and other things are kind of the start of what's called a progressive web app, which is less web and more app. It's kind of blurring a line here. I like to think of it kind of as a web native app. Like you go to a website and you have an app. There's ways to install these things now. You go to a website, it'll pop up a, hey, install this on your homepage or your home screen. There we go. So there's a lot of things I didn't cover, but just some things to kind of take a look at. There's now a browser API for websites to handle open with URLs. So for example, if you want Gmail to open up mail links, when you click on mail link, it'll open your browser and Gmail. Notifications, that's actually really fun. I built a web app just a couple days ago to notify me when overnight loads are done, and they show up in my native notification area. Auth is fun. Your browser is your account. I don't have to use Twitter as an account. I don't have to use Facebook as an account. I don't have to use Google as an account. My browser is my account. Same thing with payments. Just direct from my browser to the website. GPU access. WebGL was a thing, but now they're going different. WebGL didn't really catch on very much. And 3D graphics may be more of a niche than I'm thinking of. But speech is actually getting pretty interesting these days. Not only speech input, but also speech output, text to speech. And VR and AR are just now, I don't know if they're ramping up steam again. VRML is old, but they're doing new things, and maybe it'll work this time. I don't know. That's what they said about 3D TVs, I guess. There's some other things. The web accessibility interface, or ARIA. We can have fonts now, so you can put a font in your web page, and it will download it to the user automatically. So we don't have to just use WebDings or Comic Sans. We can make absolutely sure that they have Comic Sans when we want them to. But also, there are fonts now that just consist of icons. And those are really nice for building UIs. I can now have rounded borders. I don't have to use images for that. But I can also have layered backgrounds. So if I have, I want one thing up in this corner and one thing up in the bottom corner, I don't need to have two different elements. I can just put two backgrounds on the same element. And indeed, CSS can make up images like gradients, and it can alter images. You can filter them, transform them, etc. One of the more interesting things that I wish I knew more about is web metadata, in that you can annotate your website and say that this element describes a person's name, this element describes a person's address, and then search engines especially can use this to display kind of a preview of this content, or Facebook, Twitter, they do this thing too. So that is what essentially the last 30 years have brought. It's just so many new possibilities, and so many new possibilities coming just a little while. And I've had such fun doing this, and I can only wait to see what happens next. So does anybody have any questions? We've got a couple minutes here.
You can either raise your hand or you can just unmute and ask. It's either way is fine.
Unshare. Oh, stop share. Ah, okay, there we go.
I don't have a question. I just want to say that was an excellent summary. I mean, I'm not a web guy, but yeah, I remember lots of this stuff that you were talking about. But,
oh yeah, like
very good summary.
Yeah, I was surprised after I wrote that first section, and then I looked at where I was in the timeline. It was the new millennium. I haven't even graduated high school yet.
Are you going to continue to have co-presenters?
Sorry? Oh,
are you going to continue to have?
I don't know. She apparently decided to just take a nap. Apparently, naps are things at work now. I don't even know. No, my cat has figured out that when I'm talking, when I'm sitting here and talking, that means that I'm in a meeting, and that means I'm not paying attention, and she can climb on my lap, and I will absent-mindedly pet her until I realize that she's not supposed to be on my lap. And so, yeah, I really just ought to give in, but it's just so hard. She's so cute.
Cat top computing.
Have you been adding any new features to Yancey with new web technologies?
So Not yet. There are things I want to do, absolutely, especially in offline sync. So service workers, it'd be really nice if a user is using the editor, and if they lose temporary connectivity, we shouldn't have to care. But also auth, the web auth. I really, really, really like the idea of the browser as the auth, and I really, really, really dislike how all of my OAuth things follow me around. Like, I don't think that random forum website needs to be able to post to my Twitter feed, even though they all ask for it. Like, and we can't deny them because whatever. So yeah, not much. I use Vue for data binding. I have to rewrite that editor a little bit to make it more of a single page app and more addressable. So you can deep link into the app. That's, I guess, one of the big things about the web as opposed to a desktop app is, how do you send a user to a specific place in a desktop app? Like, how do you say here? You have to do like a 20-step like document on how to get there. Click here, click there, and just hope that their app is the same as yours. But whereas with a web app, I can just say, here, go to this URL. There I am. That's the exact place that I'm looking at. So it pains me when I see an app that can't do that. But and well, Yancey is one of them, and so I got to fix that.
Is there anything you can say about Mojolicious in terms of the history of it? Because I use Dancer, and I've been trying to switch to Mojolicious for some things, and especially the asynchronous things, and I guess what I found was people said, well, Mojolicious had problems, and then suddenly it just worked. That was kind of the story. And so, like, what was that about? What was the history moment where it just suddenly worked?
That is an excellent question. So I believe for the early days of Mojolicious, I was working for a company that developed their own web application framework / CMS. So I watched with great interest, but I wasn't really kind of part of it. I know that Mojolicious does take a different view towards backwards compatibility, in that Sebastian is absolutely fine with breaking things if they need to be broken. Like, for example, when that you can do root escalations through a CGI thing. I think that was Bugzilla that guy found the vulnerability in. Like, that very day, Mojolicious broke compatibility with its previous version and made it so that you couldn't do that. And well, so did the rest of the stuff. And Perl, that was a interesting moment. But so yeah, the other thing, I guess, is yeah, the reason it broke compatibility in the first place with Catalyst was to be asynchronous. And so there is a little bit more of a support burden in upgrading, but as I was just thinking about earlier at Sawyer's talk, like, why do I think that I can change everything about my app except the code of the app? So that is the OS, the tool chain, the libraries, everything, the browser that I'm using to view it. And why do I think that that's not, like, that I should always be able to do that, and my app will work exactly the same as it always has? And it seems kind of crazy. But that being said, I'm a pragmatist, not a prescriptivist. So, like, I'm definitely for using whatever you find comfortable, but also there's no reason why you couldn't use both. Like, use smaller Mojolicious Lite servers for whatever WebSockets you need, and keep your library of Dancer applications as you need.
I was just curious what that moment was where things started working.
Excuse me. Sorry. We need to end the Zoom session so that the next session can begin. Unfortunately, we can't
All right.
overlap.
Yep.
So
Thanks.
you can take questions to